This lesson is for section 7.5. We're going to be doing long division of polynomials. So our main objective for today is to divide polynomial expressions using long division. So this is just one method. Tomorrow we'll learn a second method, and that's called synthetic division. So long division is actually a method that you're probably already familiar with. Way back in 3rd and 4th grade, your teacher would have introduced to you how to long divide two numbers. So we're going to extend that idea to dividing polynomials. So first I just want to refresh your memory on how to divide these two numbers. Now the number in the numerator has a fancy term for it. It's called the dividend. The number in the denominator is called the divisor. So down here below we also have a dividend and a divisor. Okay, but I'm kind of getting ahead of ourselves here. Let's focus on how to divide 4,892 by 4. So your teacher probably would have put it underneath this bar, and I actually looked up the name of this bar because I couldn't remember it, and the reason I couldn't remember it is because it has no name, so it's the no name bar. Anyhow, your teacher would have began the lesson probably by saying, when you guys try to divide 4,892 by 4, you'll ask yourself, how many times does 4 fit into 4? It fits in there one time. Then they'll ask, how many times does 4 fit into 8? 4 fits into 8 twice. Now, 4 fits into 9 two times, but it has 1 left over, a remainder of 1. So then they would have brought that 1 down here, because they subtract 9 minus 8 to give you 1. They bring down that 2, and they say, how many times does 4 fit into 12? 4 fits into 12 exactly 3 times. So 4,892 divided by 4 is 1,223. This is the quotient of 4,892 and 4. Now in number 2, I wanted to show you an example where you end up with a remainder. So if we divide 1,024 by 3, first of all, 3 doesn't fit inside of 1, so I need to look at 10. So 3 fits inside of 10 3 times, and I'll place a 9 underneath because 3 times 3 is 9. Then I subtract 10 minus 9 gives me 1. Since 3 doesn't fit inside of 1, I need to carry down that 2. So now 3 fits inside of 12 4 times. 3 times 4 is 12. If I subtract here, I get 0, so I'll bring down that 4. Now 3 fits inside of 4 once, but this time it has a remainder of 1. So a remainder here of 1 means that when I write this answer, this quotient, I need to write that as 341 and 1 over 3. So I take the divisor and I need to make sure I write that remainder over my divisor. So that's the exact same process that we're going to apply now to long division of polynomials. So in our very first example here of dividing polynomials, I have a 4-term polynomial in the numerator, and I have a 2-term polynomial, which we call a binomial, in our denominator. So what I'm going to do is set up the dividend. Remember, this is called the dividend. This is the divisor. I set it up the exact same way that we set it up with just normal numbers. So I'm going to take that polynomial 3x cubed minus 2x squared minus 13x plus 14. I place that underneath our bar that has no name, so that no name bar here. Then I take the divisor, the x minus 2, and I place that here on the outside. Okay, so clearly we see that the setup is the exact same as what we used above with just the numbers. So when we took 4,892 and we divided it by 4, we first asked ourselves, how many times does 4 fit inside of 4? Fit inside of there one time. Now after that, we should have taken, and I didn't show the scratch work here, but we should have taken 4 times 1 and multiplied that to get 4, and then subtracted that amount from this term here. We would end up with a 0, and we would bring down this 8 here. So watch how I mimic that same exact idea. Now when I ask myself how many times does this dividend fit inside of this first term, I don't actually look at the negative 2. I only pay attention to that first term in my dividend. So I ask myself, how many times does x fit inside of 3x cubed? Now that term fits inside 3x squared times. Now if you're asking yourself, how does that fit in 3x squared times? Think about how you would take 3x cubed and divide it by x. That tells you how many times x fits evenly into 3x cubed. So if we divided 3x cubed by x, we would end up with 3x squared. That's just exponent properties right there. Notice I also wrote the term 3x squared above the 2x squared term. So I matched up the quadratic term with this quadratic term underneath. Okay? Alright, so again, I just asked myself how many times this leading term fits inside the very first term here. So I got 3x squared. Now I take that number, or this term, 3x squared, and I'm going to multiply it by the dividend. Just like here, I multiplied 1 and the 4, and I wrote that number underneath. So if I multiply 3x squared times x minus 2, and you can do that in your head actually, you don't need to show the scratch work, but if you multiply 3x squared times x minus 2, you end up with 3x cubed, then minus 6x squared. Okay? Remember, we subtracted that 4 here underneath, and we're going to do the same thing with this term here. We'll subtract it. So one of the areas where students will mess up is that they don't put parentheses here around the whole thing, and they forget that they're subtracting. Now the point of writing this underneath is to show that the 3x cubed and this 3x cubed here, because we're subtracting, these end up canceling. Our second terms though, negative 2x squared minus a negative 6x squared, actually turns this into a plus 6x squared. That gives us 4x squared. Now over here, you know, when we got that 0, we brought down that next term. I'm going to do the same thing here. I'm going to bring down that next term, this negative 13x. I don't need to bring down the other remaining terms, I just bring one term down at a time. So now, again, I ask myself, how many times does this leading term here fit inside? But this time I look at this number here. Just as here, we looked at 4 and how many times it fit inside of 8. Okay? So x fits inside of 4x squared, positive 4x times. Again, look at how it's matching up right above that linear term here. So again, I do the scratch work on the side, but I take that term and I multiply it by the dividend. So I'm going to erase the other arrow here. So I'm doing 4x now times x minus 2. If I take 4x times x minus 2, I'm going to do this in another color, I get 4x squared minus 8x. Again, we are subtracting this amount, so I'm going to put that whole thing in parentheses. And then I do the subtraction here, 4x squared minus 4x squared, that term cancels. Negative 13x minus a negative 8x, that turns to a positive 8 now. So I end up with negative 5x. Now I'm going to bring down that 14, so I have negative 5x plus 14. Now I ask myself, how many times does x fit inside of negative 5x? So x fits inside of negative 5x, negative 5 times. Let's write that one in blue here. So that fits in there negative 5 times. So then again, I take this negative 5 and I multiply it by this term on the outside, that dividend. If I take negative 5 and I multiply it by x minus 2, I will get, let's do this in purple, so I'll get negative 5x and then plus 10, right? Because negative 5 times negative 2 gives me a positive 10. All right, now remember, we are subtracting this. So we'll put that in parentheses and we'll subtract. So here, if you were worried about the fact that those aren't canceling, now they clearly do because we have a negative 5x minus a negative 5x. So here, this is really going to turn into a positive 5x. And that's going to switch this next sign here to a negative 10. So these cancel, leaving me with 14 minus 10, which is 4. So now I have something called the remainder. Okay, this is our remainder because x clearly does not fit inside of 4. We can't take 4 and divide it by x evenly. Now, the way we write our remainder is similar to how we wrote our remainder when we tried to take 1024 and we divided it by 3. We ended up with 341 with a remainder of 1, so when we wrote our final answer, we said 341 and 1/3. We took that remainder, the 1, so remainder of 1, and we took that number and we wrote it over our divisor. So I'm going to do the same thing here. Whoops, we've got a remainder of 4, okay? But when I write my final answer, I don't like all this crazy messy work, so I'm going to write it off to the side here. I'm always going to box my final answer. The quotient of 3x cubed minus 2x squared minus 13x plus 14 over x minus 2, that quotient is 3x squared plus 4x minus 5 plus 4 over my divisor x minus 2. So again, this is my remainder written over my divisor, okay? So this is my final answer. This is the quotient. So this represents the quotient of these two polynomials when they are divided. All right, so I realize that that's our first time we've ever seen this, and that could be very tough to follow. So you might need to replay some of that, but I am going to show you a few more examples, all right? So we're going to take, again, our dividend, place it underneath the bar. So we have 4x cubed plus 10x squared minus 12x minus 30. I place the 2x minus 3, or plus 3, on the outside here. Now I ask myself, how many times does 2x, remember I just ignored this 3, I ask myself, how many times does 2x fit inside of 4x cubed? So 4x cubed divided by 2x gives me 2x squared. So 2x fits inside of 4x cubed, 2x squared times. I place that above that 10x squared here. So I have 2x squared now. I have to multiply that by this polynomial here. So I end up with 4x cubed plus 6x squared. Now I'm going to put that in parentheses and I'm going to subtract that term from here. So that whole expression is subtracted from the one above it. These will cancel. I'll have 10x squared minus 6x squared. That leaves me with 4x squared. Now I'll bring down that next term, the negative 12x. Again, I ask myself the same process. How many times does 2x fit inside of 4x squared? 2x fits inside of 4x squared. 2x times, and it's a positive 2x, that's why I'm writing a plus 2x here. Then I take that number, 2x, the expression here, and I multiply it by that polynomial here on the outside. 2x times 2x plus 3 gives me 4x squared plus 6x. Again, if you need to see that scratch work, this is what I'm doing off to the side. 2x times 2x plus 3 gives me 4x squared plus 6x. Now I take that and I subtract that amount. I put it in parentheses to remind myself that I am subtracting here on this next term. This one's easy to remember that you're subtracting because it's right there, the sign is right there. Here it's really easy to write this number here as just negative 6. But really, negative 12 minus 6x gives me negative 18x. So it's very easy to make that mistake, so make sure you put parentheses around there so you remember to distribute that negative. All right, we'll bring down now that negative 30. So we ask ourselves here in this problem, how many times does 2x go into negative 18x? Now 2x goes into negative 18x negative 9 times, okay? So I write a minus 9 here at the top, and I take negative 9 now, I multiply it by this polynomial here, 2x plus 3, and I end up with negative 18x minus 27. So again, I take that, and if you need to see the scratch work, this is how I came up with that polynomial, negative 9, and I distributed it to the 2x plus 3. So I'll put that in parentheses to remind myself that I am subtracting. Notice I keep saying the same things over and over and over because I know you guys will make mistakes there. So please make sure you remember to subtract. So now this ends up canceling, right? You'll have negative 30 minus a negative 27, which makes that a positive 27, giving you a remainder here of negative 3. It's a remainder because 2x does not fit inside of negative 3. So I'm going to write my final answer here. So I have a remainder of negative 3. Write my final answer as 2x squared plus 2x minus 9 minus, this time, 3 over 2x plus 3. So I have this minus sign in between because my remainder is negative. Okay? So it's a negative 3. I write that as minus 3 over 2x plus 3. Don't write it as minus a negative 3 because that's really a positive. So let's get rid of that. And that would be my final answer. So clearly that does go a lot quicker, obviously, once you've learned the steps. It's a lot of work, though. And it's a lot of work where you can make some small mistakes. So let's move on to the next example. All right, now problem 5 is actually a little bit trickier how we set this one up. I still use the same dividend, so I keep that x cubed plus 5x squared minus 2x plus 4, and I set that up the exact same. However, when I take that divisor, this x squared plus 3, I notice that it's skipping from a quadratic straight to a constant, so it's missing that linear term here. Really, though, that polynomial is x squared plus 0x plus 3. This 0x is really important when I try to divide polynomials. That's called the placeholder. We need that placeholder, well, to hold its place. That place value is really important. So when I write this divisor here, I'm going to write that as x squared plus 0x plus 3 on the outside. Please remember you need to write that term in here. So now when I divide, it's going to go like normal, but here I've got 3 terms. Don't let that throw you off. You're still going to check how many times does this first term fit inside of here. So x squared fits inside of x cubed, x times. I'm going to write that above the x, the linear term here, the negative 2x. And then I'm going to multiply that x times this polynomial here on the outside. So if I take x times that polynomial, I end up with x cubed and 0x squared. So notice I end up with a 0x squared. The x squared appears under the x squared term. If you didn't have that placeholder, you probably would have written a 6x squared there, or 6x, in which case that would be definitely wrong. All right, then I take x and I multiply it by 3, and I get 3x. Remember, you are subtracting this amount, so we put parentheses around there and we subtract here. X cubed minus x cubed cancels. 5x squared minus 0x squared leaves me with still 5x squared. Negative 2x minus 3x gives me negative 5x. All right, now I'm going to drop down that 4, so I have plus 4 here. So now I ask myself, how many times does this x squared term fit inside of 5x squared? So x squared fits inside of 5x squared positive 5 times. So let's keep the color here the same. Let's write that as plus 5. Okay, now I'm going to take that 5 and multiply it here by that polynomial on the outside. 5 times x squared plus 0x plus 3 gives me 5x squared plus 0x plus 15. Again, I'm subtracting that value, so I'm going to subtract that whole expression. 5x squared minus x squared cancels. Negative 5x minus 0x leaves me with negative 5x. And 4 minus 15 gives me negative 11. So it's important here, if you forgot that that was minus, you might write that as a positive 19. So you'd be very off on this last couple problems, or these last few numbers. All right, now, this time when I try to see how many times x squared fits inside of negative 5x, this does not fit in evenly. Okay, x squared does not divide evenly into negative 5x. So we have a remainder here. So our remainder is 1 degree less than the divisor. Okay, if you notice, that happened in the last problem. Our divisor had a linear term. I think it was x minus 2. I don't want to scroll up and lose my place, but that term, whatever we used as the divisor, was 1 degree larger than the remainder. The remainder was just like a constant 4. So that term here, this is really x to the 0, this is x to the first. This is always going to be 1 degree less than your divisor. It's kind of technical, but that's one way to check to see if you've done the problem correctly, or if you have a remainder. You know, that remainder cannot be the same degree. It's always got to be 1 degree less. All right, so anyhow, let's work on writing that remainder. Even though it's a polynomial here, even though you have 2 terms here, that's okay. Your final answer should be x plus 5 minus, in this case I'm going to write minus because I can take out that negative, factor out the negative from negative 5x to negative 11 to write that as 5x plus 11 over my divisor x squared plus 3. Okay, so another way that you could write this as well is x plus 5 plus a negative 5x minus 11 over x squared plus 3. This is the preferred way to write this, but it's okay to equivalently write that down here. That's the same exact expression, okay? But eventually we're going to get you used to doing this because it'll help you later on. Okay, the last problem on here, number 6, is on here on this note sheet for a particular reason, and that's because in this case our dividend actually skips terms. Notice how we're missing a cubic term and we are also missing a linear term here. So when we write this and we try to do this by long division here, we're going to write that dividend underneath our no-name bar here by showing that we're missing that cubic term with a 0x cubed. Okay, you need to make sure you write in those placeholders. So I have 0x cubed and a 0x that are going to go in there. If I don't write those in, my answer is going to get all jacked up. You're going to end up with a lot of issues when you try to do this long division. So please make sure you're always writing in the placeholders. So I would check that. That's before you even approach a problem. I would check to make sure you need if you need placeholders or not. Okay, after that, after I've set it up, notice that I don't need to do anything to the divisor because it's in descending order, so that's fine. But now I look and see how many times does x squared fit into x to the 4th, and it'll fit in there x squared times. So now I multiply x squared times this polynomial here on the outside. That leaves me with x to the 4th. Then x squared times negative x leaves me with negative x cubed. So clearly you can see how you're going to end up with an x cubed term. If you didn't have that placeholder here, you'd get very confused. Or you would just skip it and pretend like it didn't happen. But don't do that. That should be an indication to you that you might have forgotten something if your terms don't match up. Okay? All right, then we have x squared times 1. That gives me positive x squared. And then I'm going to subtract that whole polynomial here So I end up with these canceling. And then I have 0x cubed minus a negative x cubed. That'll obviously turn into a positive x cubed here. Then I have x squared minus x squared. And that leaves me with 0x squared. So I'm going to write that 0x squared term down here because I also want to bring down the 0x here. Okay? Now, again, I only care about this leading term and this leading term here. How many times does x squared fit into x cubed? That fits in x times. So now I have to multiply x times this polynomial on the outside. So I have x cubed minus x squared this time. X times negative x is negative x squared. Then x times 1 gives me a positive x. Remember, you are subtracting this whole amount. Let's put in parentheses and subtract that. These will cancel. 0x squared minus a negative x squared gives me a positive x squared. 0x minus x gives me negative x. And I forgot to bring down the 1 here. Let's bring down that 1 now. Or no, I didn't forget, but now I need to bring it down. So I have that plus 1. All right, finally, I asked myself, how many times does x squared fit into x squared? Now, if you have caught on to things, you might notice that this is the exact same expression as this divisor, x squared minus x plus 1. So when I show that, again, x squared, how many times does it fit into x squared? It fits in there 1 time. When I show the multiplication underneath, 1 times x squared, 1 times negative x, and 1 times 1, and you try to subtract here, every single term is going to cancel out, meaning you have a remainder here of 0. So what this is actually telling you is that x squared minus x plus 1 is a factor of that. So if something divides it completely evenly, then that means that this and these both are factors of x to the 4th plus x squared plus 1. But anyhow, the original problem here is just to divide the polynomials. So we end up with this guy on top, x squared plus x plus 1. All right, so that would be my final answer here. And again, what that is saying basically is that if you took x squared minus x plus 1, the divisor, and we multiplied it by our quotient, x squared plus x plus 1, we would end up with x to the 4th plus x squared plus 1. Very, very interesting. But anyhow, there's my final answer, and that is the end of the lesson. Nice job. I will see you guys in class tomorrow.